So before we do the limit as n approaches infinity, we're going to do the limit as x approaches infinity. And then we'll talk about what's the difference between those two. But if the limit exists, then it's actually, what we're describing here is the end behavior of the function, which is a word that we haven't used a ton, but it basically is there a horizontal asymptote on this thing? If there's a horizontal asymptote, that means the value of the function is approaching that as x approaches infinity. And that's something that we did back when we did rational functions, back when we did functions that could be written like a polynomial in the numerator, a polynomial in the denominator, and the rules about finding horizontal asymptotes were all dependent on the degree of the numerator and the degree of the denominator. If you remember, we had three rules. When the degree of the numerator, meaning the highest power of x, is more than the degree of the denominator, there is no horizontal asymptote, so there is no limit. There would be no limit if we took the limit of that function as x approaches infinity. If the degree of the numerator was less than the degree of the denominator, then the horizontal asymptote was y equals 0, which means the limit would be 0. And if the degrees were equal, remember it was y equals a over b, where a and b were the coefficients of the highest degree terms in the numerator and the denominator. So that's the limit. So it's the exact same three rules that we use to find the horizontal asymptotes. Those are the rules we use to find the limits as x approaches infinity.